Ooh, wow. Hello, lovely people. I hope you are doing well. So, I am going through a shadow paper and let's get right into it. You'll hear me think, you'll hear how I approach these problems. I've not necessarily seen all the questions. I kind of had a quick flick through, but let's test these out. So, the first question is saying b is less than the square root of a, and circle the correct equation. B is 4 less than the square root of a. Okay, so 4 less than the square root of a. So we need to establish what the square root of a is. Well, that's just root a. And then 4 less is to take away. So it's going to be this option over here. Next, circle the smallest number. The easiest way to do this, I think, would just be to write it to more decimal places. So 0.6 recurring, let's see. Let's say if I wrote them all to 5 decimal places, it might be easier. 0.66666. This next one, 0.66, and then 000. This next one, 0.65600. And then the next one, 0.656 recurring, but only the 5 and 6 are recurring. So 6, 5, 6, 5, 6. So all this number goes on. This one stops, and this one goes on. But we can see here that this one is clearly biggest, this first one. And we can see here that the smallest number is actually going to be this one. Writing it to the same number of decimal places makes it much easier. Okay, next, the Linus equation 4y equals 2x minus 3. Circle the coordinates of the intercept of the line with the y-axis. Okay, so wherever something intercepts the y-axis, that is when x equals 0. So with this equation, we're going to write 4y equals 2 lots of 0 minus 3. So 4y equals minus 3, because 2 times 0 is just 0. Minus 3 is minus 3. So then y is equal to minus 3 over 4. So when x equals 0, y equals minus 3 over 4. So it's this option over here. You guys can do this. Let's go. Okay, we've got number 4. Factorize y squared minus 81. Okay, well, this one's just the difference of 2 squares, isn't it? So we've got 2 brackets. Square root of y squared is y. The square root of 81 is 9. And then 1 is plus and minus. So it's going to be this option here. Next one, 5 positive numbers have a mean of 8, a range of 10. 3 of the numbers are 3, 7, and 12. Work out the other 2 numbers. Okay, well, let's look at it like this. So if we know the mean is 8 and there are 5 numbers, this tells us that the 5 numbers multiplied, well, they add to 40, because if they have a mean of 8 and there are 5 numbers, then mean multiplied by the number of numbers you have gives you the total, right? Which is 40. So we know they have to add up to 40. So add to 40. Now, range of 10. One of 2 things can happen here. Let's suppose that we make 12 the biggest number and it has a range of 10. Range, remember, is biggest number take away smallest number. That means that if that is to be 10 and 12 is the biggest number, one of the numbers would have to be 2, right? Because 12 take away 2 would be the range, which gives us 10. Then these numbers also have to add up to 40 because of the requirement above. So if we did 2, what's going on here? If we did 2 plus 3 plus 7 plus 12, Well, that would give us 24. And then remember, all the numbers have to add up to 40. So we do 40 minus 24, giving us 16. So our last number would have to be 16. That's a problem, though. That's a problem. Because if we decided that 12 was to be the biggest number, then we can't have 16 because then that violates our rule. So we got to rethink our strategy here. So let's go back. Let's go back. Okay, so the way this is going to have to work is instead of 12 being the biggest number, we can make 3 the smallest number. And if our range is going to be 10, remember it's the biggest number, take away the smallest number. So one of our numbers is going to have to be 13. So 13 take away 3 would be 10. Now, if we do 3 plus 7 plus 12 plus 13, well, that's going to give us 35. And then 40 take away 35 equals 5. So our final number is going to have to be 5. And that does not violate our principle because 3 is still the smallest number. So that is all good. It works. So our numbers are going to have to be 13 and 5. Let's keep going. Okay, let's look at number 6. At an adventure park, there is a zoo, a fair, and a cafe. The table shows the prices per person to visit the park. And people can go just to visit the cafe, so that's free. If they want to visit the zoo and the fair, that's going to be £27.50. If they only want to visit the zoo, that's going to be £18. And if they want to visit the fair only, that's going to be £17. Cool. One day, 4,200 people visit the adventure park. Is that a lot of people? I don't even know. Anyway, so it says 67 people visit the cafe only. So they've put that outside the Venn diagram. Fine. So basically neither the zoo nor the fair. And it says 45% visit the zoo. 2/7 visit... 45% visit the zoo and the fair, rather. 2/7 visit the zoo only. And the rest visit the fair only. In total, how much do 4,200 people pay to visit the adventure park? Okay, well, it says you may use the Venn diagram. Now, that doesn't mean we have to, but if they're saying you may use it, we may as well use it, right? It's going to be easy for us, so let's do that. Okay, so we have 45% who visit the zoo and the fair, so that's going to come in this intersection over here. So cool, let's do that. All right, in that case, that means that we take 45% of 4,200, and that is going to equal, so 0.45 times 4,200, just doing that on my calculator, that's giving me 1,890. Cool beans. 1890. Okay, then it says 2/7 visit the zoo only, so we've worked out 2/7, so just typing in 2/7 in the calculator, 2/7 times 4,200. Please don't judge me. I know I probably could have done this in my head, but whatever. Nah. So that's going to be 1,200 who visit the zoo only. So that's 1,200 here, the zoo only. And the rest visit the fair only. Well, if it's the rest, then we're doing 4,200 take away what you get when you add all these numbers. So 67 plus 1,200 plus 1,890. And what is that going to be? What is that going to be? So take away 67 plus 1,200 plus 1,890. Okay, that's all right. 1,043. I'm saying that's all right. I don't know why I said that's all right, but it's okay. So that's that. So we filled out the Venn diagram, but we're not done. We're not done with the question. Now we've actually got to use the information and work out how much money was made from each section. So we know 67 people visited the cafe. They pay 0, so that's 67 times 0. So that's nothing there. We know 1,200 people visited the zoo only. and each of those people paid £18. So we can do 1,200 times 18. So 1,200 multiplied by 18 is going to give us 21,600. And that represents the pounds. So I should really have put pounds like that. Okay, let's change the color. This is a good color. For the people who visited both the zoo and the fair, well, that was 1,890 people. So 1,890 times by their price, which is $27.50. So 1,890, 1,890 times 27.50, and that is going to be 51,975. That is all good. Let's change color again, just because, you know, it's good. Then we've got the people who visited the fair only, which is 1,043. And that's times their price, which is £17. So 1,043 times by £17, and that is going to be 17,731. So 17,731. Okay, now what we need to do is add up all of those prices, of course. So let's write that. Let's just use black. So we've obviously got the 0. Don't leave out the 0. Plus £21,600 plus £51,975 plus £17,731. And what does that give us? Just going to use a calculator because we can. 21,600 plus 51,975 plus 17,731. And that is going to give me £91,306. So £91,306 is the amount of money that was made on that one day. Cool. All right. Let's go back to blue. Let's go for a darker shade of blue. Let's go for this one. This looks good. All right. So next. Adam and Kitty share £312 in the ratio 3.8 to 1. What a ratio. How much more than Kitty does Adam get? Okay, right. I nearly read that incorrectly. Notice how I'm reading this question many times. Or maybe you won't notice, but I'm reading it a lot of times just to understand. So Adam gets more money. How much more does he get? Okay, there are quite a few ways we can do this. I mean, we can just do it like the direct way, but the direct way, which isn't necessarily the quickest way. I think it's just good for people to understand. So altogether, we have 3.8 plus 1. So, oh my gosh, not 3 plus 8, 3.8. And that is equal to 4.8. And so the 4.8 parts that we have here represents the 312. So one part is going to be just 312 divided by 4.8. Again, we've got a calculator, so please, let's go crazy with this. So that gives us 65. Okay. And in fact, Kitty represented one part, so Kitty gets 65, which is good. And then Adam, he's going to get 3.8 parts. So 3.8 parts is going to represent 65 times 3.8. So just doing that on the calculator, and that gives 247. But the question was how much more? So we need to work out the differences in those prices. So that's going to be 247 take away 65. Yep, I'm shamelessly using the calculator the calculator's there. You better believe I'm going to use it. So it's 182 pounds more. And there we go. Okay. Next, a widget compressor exerts a pressure of 258 pounds per square inch. Convert this pressure into kilograms per square meter. Okay, well, so the pressure is, 258 pounds per inch squared. Convert this into kilograms per centimeter, per square centimeter. Okay, that's fine. That's fine. So we've got 258, and that's pounds per square inch. So I'm going to put inch squared. That's the units, right? And they want us to convert this pressure into kilograms per square centimeters. Now, you've got to be quite careful with this. You've got to be careful with this compound measurement. So first things first, we're going to change the pounds into kilograms, and we're going to change the inches into, well, the square inches into square centimeters. So basically what's going on here is I'm going to put 258. I'm going to put this as a proper fraction. So this is essentially multiply by pounds per inch squared. So that is, that's what the units are telling us. It's essentially a fraction. So I've just rewritten it so that it's easier to look at. And now that we know this, well, I'm going to put 258 multiplied by, so a pound is 0.45 kilograms. So I'm going to put 0.45 kg. Okay. Divided by square inch. So we know that 1 inch squared is 6.25 square centimeters. They told us that. So I can just change the inch squared to 6.25, like that. And now I can actually just calculate that. So, and that's 6.25 cm squared, specifically. Always put the units. And now I can just simplify this fraction. So I can do 258 times by 0.45, then divide the answer by 6.25. And that's going to be some number, and that's going to be kilograms per centimeter squared. So it's so much easier when you can approach it in this kind of way. So 0.45, 0.45 over 6.25. That gives us 18.576 kg over cm squared. So our answer is 18.576, and the question or the paper itself gives us the units over here. So we're good. That's it. Next question. Square ABCD is split into 4 smaller rectangles. Okay, so we know it's a square, which is important. 2 of the smaller rectangles are shaded. We know the ratio of 3 to x is 3 to 1. And it says, for square ABCD, work out the ratio of the shaded area to the unshaded area and give the answer in the simplest form. Okay, this is interesting. Alrighty, so what do we know? Okay, this is an interesting one. This is an interesting one indeed. So it's been split into 4 smaller rectangles. This is just me thinking. So now you actually get to see what happens when I encounter an unknown kind of problem, and hopefully my thoughts process will work. Okay, so let's see. Yeah, I've got to make this bigger now. What is going on? So 15 centimeters squared, 120 centimeters squared, Okay, so first of all, well, one thing that I can say is the length over here is 3 plus x, and the whole length, and the length over here is also 3 plus x. So the area of the full thing is 3 plus x all times by 3 plus x. I'm just going to write that thought down. So area of ABCD, it may or may not help, but we see. So the area of ABCD equals, I'm going to write it as x plus 3 rather than 3 plus x. It's the same thing. X plus 3 times x plus 3, which is x squared plus 6x plus 9 when you expand and simplify. What else? We know the ratio of 3 to x is 1 to 4. Oh, okay, that's fine. That's fine. To be honest, did I even need to do that? I think I was just having a bit of a moment there. Okay. So if the ratio of 3 to x is 1 to 4, well, I can just multiply this ratio by 3, as in both these bits here. So that becomes 3, 1 times 3, and 4 times 3 is 12. So we know basically the x bit is 12. Okay, that's fine. That is fine. Okay, so basically this is 12. So that means the whole thing is 15. Yeah, so I can change this now to 15. So I'm going to rub this bit out, put 15 instead. Going to rub this bit out, put 15 instead. That means that the area is going to be, instead of just, yeah, it's going to be 15 times 15. And that just comes out to be 225. That's useful. That is useful indeed. In fact, if we know that, well, we also know the area of the unshaded bit because they've given it to us. So the unshaded bit, so unshaded area is going to be equal to 15 centimeters squared plus 120 centimeters squared, which is 135 centimeters squared. We know the area of the full square is 225. So 225, that is 135, by the way. 225, take away 135. Shamelessly use the calculator. Please, I'm going to use the calculator to avoid any unnecessary errors. It's not a risk worth taking. So the unshaded area together is going to be 90. So this combined bit gives 90. So the ratio of the shaded area to the unshaded area, well, that's 90 to 135. And I'm just going to simplify this ratio. So what can these be both divided by? They can both be divided by 5. So if I divide the 90 bit by 5, well, that becomes 18. 135 divided by 5, I think it's 27. Yeah, it's 27. Can these be divided by anything? Yes, they can both be divided by 3. So, in fact, they can both be divided by 9. So divide the 18 by 9, giving me 2. And divide the 27 by 9, giving 3. Perfect. So it's in the ratio 2 to 3. How about that? So, did I get it the right way around, first of all? Shaded was 90. Yep, shaded to unshaded. So that's 2 to 3. Okay, let's keep going. A solid shape is drawn on isometric paper. Okay, that's fine. On centimeter grid, draw the elevation of the shape from A. Okay. So we've got here. Fine. What I'm going to do actually is I'm going to split this up into nice squares, because this is square centimeter paper, like centimeter grid, right? So if I just draw lines like this, I can see how many, very clearly, how many squares it actually takes up. So from this end, we can see that there are 4 here, and these ones are facing not in the same direction as his. This is actually facing that way. So I'm not going to count those ones, and I've got here 3, 4, 5, 6. So from the elevation from A, the direction of A, is going to look like essentially just 10 squares facing you. Right? So it's going to look like this. It's a rough sketch. Oh, no, that's not what I wanted to do. That's not what I wanted to do. Oh my gosh. I could have made this straight from the beginning. It's fine. Just learning to use my new toy. That's fine. Okay, fine. So there's that one bit there, and you see a bit of a ridge. And then you see... like that. So that's what it looks like from A. Okay, and then it says on the centimeter grid, draw the plan. Plan means from the top, from bird's eye view. So from the top. Start from the top. So what does it look like from here, basically, if you were to look down on it? Well, we can see, let me do it in a different color, actually. We can see you like that. We can see it's taking up these kind of squares. Yep, like that. So we can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then a further 1, 2, 3 down here. So it's like a 2 by 5 across. So let's do it like this. And then 1, 2, 3, 4, 5. Oh my gosh, that's not very good. Oh wow, that's terrible. Let's just do it like that, it's fine. I should be using a ruler. And I've got 3 underneath as well, so like that, like that, like that. Okay, that was that question.